My name is Daniel. Let's begin. In the first, we can check the information in a question. We can receive 5,000 each year. On there, 5,000 each year for 5 years, and on the last day of each year, I can receive the 5,000. So we list all information. We set the cash flow as C. The cash flow is 5,000 because we can receive 5,000 each year. And for 5 years, so N equal 5,000. And on the last day of each year, interest rate is 6%. Rate equal 6% for 5 years. And at the last day of the year, so we can make this number line. In the beginning, we don't have money because we receive the money on the number 365 days on there. In that day, we can get the first cash flow. First cash flow is 5,000. And the second years, almost second years, our first cash flow will transform C multiple first rate. That is 6%. So our first money on that time will become this. Cash flow multiple 1.06. And the next day, our cash flow will plus the second cash flow is that. First cash flow at that time will become this, and this time I also can get the second cash flow. So in that time, my money will become first cash flow plus first interest rate plus second cash flow. How about the number 3 years? In number 3 years, our cash flow will become this. A cash flow multiple interest rate and multiple interest again. So we can write as C multiple 1.06 raised to the power of 2. And how about the number n years later? In there, number n years later, we can see the previous record. The power, the exponential number is the number of years minus 1. You can see there 0, 1 minus 1, 0, 1, 2 minus 1, 1, 3 minus 1, 2. So you can see there the exponential number will become the years minus 1. So in the number n years, we will receive, in number n years, our first cash flow will become C multiple 1.06 raised to the power of n minus 1. And how can we plus all the data in the number line? We can use this formula. and this is my counting result. Count list is very complicated and waste many time, so we can use the calculator to help us. There is a calculator. We input the information. First, we input how many years. In there, we have 5 years. So first, 5 years. And interest rate is 6% per year. 6%. Present value. In beginning, our present value is 0, so we input the 0. And payment, we receive the 5,000 each year. 5,000 is our payment. But the payment is I paid. So in there, on the cash flow, we will set as the minus. Okay. Now we compute the future value. Compute future value. Oh shit. Okay. Sorry, I forget to change the function. Because we receive the money on the end of the years, so we need to change to the end mode. Yes, the end mode. And we input the information. 5,000 per year. No. For 5 years. And interest rate 6%. Present value 0. Payment 5,000. And compute the future value. We forget to add the minus to cash flow. So the result is 28,185. There is a little difference between this because we are using the traditional compute, so have something different, a little different. And now we get into the number 2 question. In the next question, we have information. We can receive a 5,002 and for 5 years, but at late time, we receive the money quarterly. We can receive the 5,000 each quarter, and the interest rate is 6%. Let's say 5 years. Okay, we have many information, and we can tidy out. First, cash flow is 5,000, and each quarter. So we can receive for for 5 years and for 4 quarters each year. So we can receive the money 20 times. Next, 5 years, 4 quarters, 20 times. As the last day, as usual, 6%. interest rate equals 6%. The way to compute is as usual as the last question. We use the same number line and same formula, but this is too waste time to compute, so you just need to watch the result. And we try to use the financial calculator to compute this again. We input the cash flow is 5,000. Oh, no. First, we receive the money 20 times, so we input 20. And interest rate for 6%. Oh, I forget. In there, our interest rate is not 6%. Because the 6% is for years. So, but we receive the money is per quarter. So on a quarter, the 6% is nominal rate. We can divide by every quarter. Each quarter we can receive the interest rate is 6 divided by 4, because 4 quarters. So each quarter we can receive 1.5%. So the rate is not 6%, it's 1.5%. Because we receive the interest rate each quarter. Okay, we input the information to the financial calculator. Cash flow, First, we input the times we can get the money, 20 times. And interest rate, 1.5. Present value, we start from 0. And the payment is our cash flow. We put the money in, so the cash flow is minus payment. Future value. What is the future value? Compute. No. Sorry, this is last time I used the wrong interest rate. This is correct. In there, interest rate is not 6%, it's 1.5%, because we receive the money each quarter, and the 6% is the interest rate per years. We check the information, receive the 5,000 each year too, and for 5 years, 6%. This is same as the first question, but the different way is we receive the money as the first day of each years. So we will change the mode to change the financial calculator mode to the BGN beginning. BGN. Later I will use this mode to calculate. to compute. And now, what's the difference with receive the money on the first year and receive the money on the last day of the years? We can use the number line to show. We can see this number line. In beginning, we have 0, 2. We don't have any money, but in the first day, in this day, it's not 0. In first day, we will receive the first cash flow. That is 5,000. 5,000 there. And 364 years later, this time, our first cash flow will become this. Will multiple the first interest rate. So 1 year later, our first cash flow will become C multiple 1 plus interest rate. And 1 year later, from first years, on the before the second year on there, our first cash flow, I forget to say. On there, we will receive the number 2, the second cash flow. So as the first year and 1 day later, our first cash flow, 5,000, become this. And let's say receive the second 5,000. So at that time, the day after 1 year and 1 day, there, 1 year and 1 day, we have the first year's cash flow and the second year's cash flow. Okay, and as late time, almost second years, our first cash flow become multiple the interest rate again, and our first year's income multiple the first interest rate. So now, at the after the 2 years, at the third year's beginning, we have the first cash flow. First year's cash flow, C. But at late time, our first cash flow become this, and second cash flow become this, and we also at this day we get the third income is C. So that time we will get the money, this plus C. And how about the number n years? In number n years, we use the previous record. The exponential number is what the years of there. So in the first year, the exponential number is 1, and the second years we rise to the power of 2. Third years we rise to the power of 3. So number n years we rise to the power of n. Okay, but how can we plus all of them? Let's tidy out. We can add all of the number in this number line. First year, first time, C, plus second year, first day, third year, first day. And this is number n years, first day. We list on there. We set the 1 plus interest rate at R, and we all of the parameter we multiple multiple 1R, so C multiple R will become C multiple R raised to the power of 2. All of that is there. And we use the second formula minus first formula. We will tidy out. We will tidy out. One minus 1 plus R raised to the power of minus n divided by R. With summation on the number will become, because this is the first day we get the money, so we will multiply 1 plus R again. This is the summation of every number on the number line. 5 years and interest rate 6%. Previous 0. Payment minus 5,000. Let's compute future value. 29,860 is 76. 29,876. Summation equal 1 minus 1.0.06 raised to the power of minus n divided by 6%, and multiple 1 plus 0.06. Oh, minus n is minus 5 because we have 5 years. We compute this 29,876. Let's go on. Number 4 question. Number 4 question. As usual, 5,000 each year, and it's like at that time we have 5,000 each year. No. This time we have 5,000 each quarter, but the interest rate is 6% each year. So we transform the interest rate to 6% divided by 4, each quarter 1.5%. and the times we can get money is 20 times. We tidy up. Cash flow 5,000, interest rate 1.5% times 20 times, and use this formula to calculate. Summation of the 5 years of the money equal 1 minus 1 plus interest rate 1.5%. So this is 0.008 0.015. Rise to a power of minus 20. Divide by 0.015. Multiple 1 plus 0.015. We use the financial calculator. First, times 20 times interest rate 1.5% each period, and present value is 0. Payment is minus 2, 5,000 payment, and we can compute the future value is 117,352 dollars. Okay, let's go on. Next question. We save 1,000 per year for the next 6 years. 6 years. 1,000 per year. Account 10% per year, very high. At the end of the 6 years, first year deposit. So we can make a number line. First, cash flow C equal 1,000 per year, and for 6 years. Interest rate is 10%. We put the money in beginning. Layer at this day C multiple first interest rate, and number second years, this will become the first cash flow will become multiple first interest rate twice, so rise to a power of 2. And number 6 years. At this time, our money will become C multiple 1 plus rate rise to the power of 6. let's go on. We can use the formula as the number 4, as the number 3. This formula, and we can list it. Summation of each year we can receive the money. 1 minus 1 plus interest rate, 10%, very high. Minus 6 years. 6 times we can receive the money. And divide by interest rate, divide by 0.1. And multiple 1 plus interest rate, 0.1. We use the financial calculator to compute. First, 6 times we can receive the money, 6 times. Interest rate, 10%. Present value, 0. And payment, 1,000 each year. Compute. We forget to add the minus to payment. The future value will become minus $8,487. Let's go on to the last question. We input the times we should pay is 180. And the interest rate is 8% divided by 12. Yes, this is interest rate. And present value is how many money we should pay. We should back to bank. Present value is 180,000. Present value. And payment unknown. The future value I will set 0 because we don't have we didn't pay the money yet. So okay, let's compute. The number is 1,708. This is the number is we should pay for the